Angles of elevation and depression. That angle is sad because he's an angle of depression. So angles of elevation and depression. Let's do a couple of definitions. So an angle of elevation is the angle formed by a horizontal line in an observer's line of sight to an object above the horizontal line. An angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. Basically, an angle of elevation is when you look up at something. An angle of depression is when you look down at something. Let's see if we can have an illustration. Look at that, we have one handy here. So in our little drawing up here, we have a fighter jet at 10,000 feet and a battleship that's on the surface of the ocean. So an observer on the deck of the battleship looks up and sees the fighter jet at 10,000 feet. So that angle of that they would be tilting their eyes up would be 20 degrees. The fighter pilot is looking down at the battleship and he has to turn his head downward at a same measurement. Angles of depression and angles of elevation are always equal. So the angle of depression that the fighter jet would be looking at would be 20 degrees as well.
Super fun math fact.
All right, so Eratosthenes, who was born in 276 BC and died in 197 BC, so about 200 years before Christ, he was a mathematician and astronomer who was born in Cyrene, which is now Libya. Libya is located on the northern coast of Africa on the Mediterranean. And he used the angle of the elevation of the sun at noon in the cities of Alexandria, which is in Egypt, and in Syene, also in Egypt, to measure the circumference of the earth. So if you've got two angles of elevation and depression, what you can do is, if you're looking at two different objects, you can estimate the distance between those objects. If you have two angles of elevation from two different positions of observation of the same object, you can use this to estimate the object's height. So we want to insert two angles of elevation and depression example problems here. So there's a young lady named Leia, and she's at an amusement park. She wants to see a castle there, and she sights the top of the castle at an angle of elevation of 38 degrees. She knows the castle is 190 feet tall. If Leia is 5.5 feet tall, how far is she from the castle to the nearest foot? Well, here's the thing we're going to keep in mind with this. Number one, we're going to be using some trig. And the thing we want to keep in mind is this little piece here of her height, 5.5 feet. The top of the castle is at 190, but this distance here between this and to this is going to be 190 minus 5.5, so it would be 184.5 feet. Now, we're going to use some trig, and we're going to solve this. So, keeping in mind now that the angle of elevation here is right here, right? And x is right here, and that is adjacent. And this segment here is the opposite. So let's think about what function we're going to use. We don't have the hypotenuse. This is the hypotenuse right here. We don't have that. So we're not going to use it. So we have to use the only one we can use, which is TOA, which is the tangent function. So the tangent, so let's go back to the tangent here. The tangent of 38 degrees is going to be equal to the opposite, which is 184.5, not 190, over x. Now, if you recall, we did this the other day. that we can switch these two out, and then we can solve for the x. So we can switch out x, and that's going to be equal to 184.5 over the tangent of 38. Here's where the handy dandy calculator becomes a really good tool to have. So you may want to pick yours up at this point, and we're going to say that 184.5 divided by, and I'm going to hit my trig function here and plug in the tangent, hit enter, and then my degrees is 38, put that in and hit the enter key, and I've got 236.149 feet. Well, since the first decimal place there is 1, we're going to round that down. So our final answer is going to be 236 feet. All right, so our next problem here, we've got a helicopter. It's a search and rescue team. They're airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 19 feet above the water, what is the horizontal distance from the rescuer to this person to the nearest foot? So again, let's take a look at what we have in our picture. We are given, here's our angle of elevation, it's at 42 degrees, right? This is the adjacent right here, and here's our opposite, and here's the hypotenuse, and that's really of no help at this point. So we're going to go with the tangent again. So the tangent of 42 is equal to the opposite, which is 18, over the adjacent, which is x. Opposite over adjacent for tangent. So we're going to switch them out again. I'm just going to remind you here, we're going to do that. Okay, we're going to switch those out. So we're going to end up with x is equal to 18 divided by tangent of 42. Again, the handy dandy calculator comes in really handy right now. So we're going to take 18 and divide that by my trig function, which is the tangent again, and this time it's going to be 42 degrees. And my final answer is 19.991. And so we want to do this to the nearest foot, so 19.99. We're going to say, hey, they're 20 feet away. Okay. Which is really probably a good thing, because there's a shark coming. There's sharks in the water. Okay, so we want to get that guy out of the water as soon as possible. What's going on?
And so I cry sometimes when I'm lying in bed just to get it out what's in my head, and I feel it a little peculiar. And so I wake in the morning and I step outside and I take a deep breath and get real high and loud, straight to the top of my lungs. What's going on? And I say, hey, yeah, 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 hey, yeah, yeah. life is still trying to get off that great big hill of hope for a destination.
What's going on? I just had to mess with you and have you look at that. Anyway.
That's all, folks.
Come on, you loved it.